What if you're not allowed to use technology? Well, the first thing to do is to draw a quick sketch. That's one of the reasons we spent so much time helping you figure out how to sketch these curves. Okay, I now have two curves, and before you say that one's too hard to sketch, it's not. It's a reciprocal of 1 plus x squared, and 1 plus x squared is a very easy graph. Now get the reciprocal. Notice you don't need any detailed coordinates at this point. You're going to solve those next. Just get an idea of what the shape of the graph is. Okay, so I've sketched my graph, and the bounded area is going to be f minus g. Okay, f is greater than g in this case. Okay, what are those points of intersection? Well, you make f of x equal to g of x, and you solve. This one's a quadratic in x squared, except this part will never be 0. So it has to be x squared minus 1. If x squared minus 1 is 0, that means x is plus or minus 1. So that made those points easy to find. I don't even need the y coordinates because I'm actually going to be integrating. Okay, f is greater than g. Now, the textbook has actually done something clever. They've also noticed that these curves are both symmetric, so they can work out the area from 0 to 1 and double it. You don't have to do that. You can go from -1 to 1. It's just that the substitution in the integration might be easier with 0. So that's what they've done. They've gone from 0 to 1 and doubled it. This is what we're integrating, f of x minus g of x. This one you should recognise by rule is arctan, and this one becomes x cubed on 3, which makes it x cubed on 6 here. Put in x equal to 1, put in x equal to 0, subtract, and there's my answer as an exact value. Again, you didn't have to do double from 0 to 1. You could have gone from -1 to 1 and just been careful with your insertions of values here. It doesn't matter, you'll get the same answer.